Hello, everybody, and welcome back to another Mr. Farney Earth Science video. Yesterday, we introduced concepts as the general rock cycle. We learned the three different types of rocks: igneous, metamorphic, and sedimentary. We spoke briefly about their differences, and we dove right into our first type, igneous rocks, where we focused in primarily on the differences between intrusive and extrusive igneous rocks, how they formed, and how they give us the differences between kind of coarse-grained rocks where we can actually see the minerals unaided, and fine-grained rocks where if you want to see the minerals in those specific igneous rocks, you need some sort of tool like a microscope or a magnifying glass. In this video, we're going to go a little bit more into texture. We're going to talk about a little bit about composition as more or less a review, things you already know. And then we'll finish up by talking about different melting and cooling patterns of igneous rocks that give us different minerals that exist within them. So sounds like a lot, but it'll only take about 5 or 6 minutes. So on the slide that you see right here, we have two pictures. The top ones are intrusive igneous rock formed deep underground. It cooled slowly, and it was that slow cooling that allowed these large, very easily visible crystals to form. This is what we mean by coarse grain. You can easily see the minerals. In that picture alone, I can see some feldspar and some quartz, maybe a little bit of biotite, maybe a little bit of the other type of feldspar, a little sodium plagioclase. So it is easy to see those minerals, compared to the bottom image where it is very difficult to see the minerals in that rock, that extrusive igneous rock, because it formed near or at the Earth's surface, cooled much faster. So it did not allow time for those crystals to form. They're either really, really tiny, or they might seem invisible because they're so tiny. You need a tool to be able to see those minerals. So intrusive are coarse-grained, extrusive are fine-grained. Then we have some special situations that can occur. We have glassy rocks where it cooled so quickly, no crystals or extremely few amount of crystals were able to form. We see that very often with our obsidian. Or you have an instance where you have porphyritic rocks, where a rock that already had crystals form. Maybe there was some partial melting that happened, and then it cooled very quickly to get that type of rock. Or you have vesicular rocks, where you have gas bubbles that were trapped in that magma, and when that rock hardened because it cooled, it left this spongy-like pattern going on in the rocks there. So glassy, porphyritic, vesicular, all of these three are special textures that are, common with igneous rocks. Now, composition-wise, we already know these words. Basaltic is our mafic magma. It's dark colored. It's very dense. We have our granitic felsic. In our past slides, we use the word rhyolitic instead of granitic, but we can almost use them interchangeably. Felsic's the key part here. That's our light-colored, less dense rocks. And then andesitics are in between. It's kind of like a combination of basaltic and granitic. We have the Andes Mountains that are formed out of this. So our three different magma types are basaltic, andesitic, and then granitic or rhyolitic, however you want to remember it, that's fine. And primarily when it comes down to composition, we're really, for our class purposes, just looking at the overall color of the rock to help us get an idea of what we're dealing with there. So igneous rocks are cool because after we get the formation of an igneous rock, depending where it's located, maybe it shifts a little bit underground, or maybe some magma rolls over it a little bit. Partial melting could occur and cause the rock to either remelt and then recool. And depending how it recools, we could get that porphyritic pattern where we already have crystals that exist, but then it's like intermixed in with like a glassy rock or something like that, because of it partially melting and then it re-solidifying. So that has to do with just the overall kind of melting temperatures of the rock, or if, partial melting occurs. It's kind of interesting. And then this idea of fractional crystallization is, I think, key in understanding how the minerals form. which then ultimately leads into being able to identify what rock you're looking at. And so the key idea of fractional crystallization is that different minerals form at different temperatures. So that means that the hotter the temperature that of the lava that you're dealing with, you're going to get different types of minerals than if you're dealing with a slightly cooler lava or magma. This picture here is called Bowen's reaction series, and it illustrates this really well. Where at very low temperature magmas, that's where we're going to get like our micas, like our muscovites, some feldspar. We saw the pink feldspar or potassium feldspar, sometimes called orthoclase, in our mineral lab. We get quartz. These are felsic types of rocks and magmas, low temperatures. As we increase in temperature, you'll notice that the minerals are going to change. We get some biotite. They use the word amphibole, but that's also hornblende if you want to say hornblende. Some pyroxene, and then at the really, really high temperatures, we can have olivine starting to form. You'll notice that there are two different types of reactions that can occur, whether it's kind of like a continuous reaction, where it's a gradual change in the mineral composition over time, or if it's very abrupt. So depending if it's continuous or discontinuous, you're going to get those different types of minerals dominating the rock. You don't necessarily need to be concerned of that for our class, but just know that this picture of Bowen's reaction series does a really good job at comparing the magma temperature to the types of minerals we're dealing with to the overall composition of the rock. So this is a really good picture that encompasses a lot of the things that we talked about in this video and in the igneous rock section. So with that being said, we're finished igneous rocks. The next step is our igneous rock lab. So we'll talk more about that in person in class. But if you have any questions for me about igneous rocks, the igneous rock section, please go ahead, reach out. I'll get back to you as soon as you can. If not, have a good rest of your day, and we'll check back with you next time. Take care.